Hello, today we're going to look at how SOLIDWORKS can be used in the process and plant design field. In this example, we're going to be looking at a naturally gas powered plant. Specifically, we're going to be looking at an area of this design that focuses on the water storage used in cooling. There's a set of bulk storage tanks and a demineralized water storage tank. Here we can see in this design it's full and complete and contains lots of processes and components, and is a really good example of how SOLIDWORKS is used in the process and plant design industries. Most of our designs, however, probably start from another source, in this case 2D. This could be civil engineering data, architectural data, but in the end we probably need to work with it, and SOLIDWORKS provides rich tools for working in a 2D environment. We can see that SOLIDWORKS provides many tools that we're used to using. In this case, we want to insert a 2D block. It's a block of a transfer skid. All we do is insert it, just like we're used to in our everyday tools, but this tool is provided by SOLIDWORKS. We can see here that we can locate it appropriately and make any necessary changes. We also have the full capability of editing the layers in our design. In this case, I want to freeze many unnecessary layers. At this point, we'll save these design changes and see how we'll use this inside of SOLIDWORKS. In SOLIDWORKS, all we do is simply open the document, and SOLIDWORKS is known for being able to open many neutral formats, including standard 3D formats and of course DWG. As we open the DWG file up, you'll notice that SOLIDWORKS recognizes it uniquely as a DWG file and allows us to make some unique modifications to it. Here we have full layer support. We can turn on and off any layers that we find necessary or unnecessary. However, we save the document as we wanted it. We simply set the units and hit finish, and SOLIDWORKS even notices that there's blocks inside of the 2D file. We want to preserve these, so we'll choose no. SOLIDWORKS imports the 2D file, and we can see by expanding the sketch that SOLIDWORKS did bring in all the blocks used in the design. This is great if we need to make any changes at a later state. We're going to move this to the top plane so it's properly oriented for our use. At this point, all we'll do is use the original 2D data to create the actual property boundary. In this case, we're going to make it 3 meters thick and select the perimeter. We'll also give it a bit of an offset here. There's also a fence that goes around the perimeter. Let's turn that sketch back on and extrude that fence as well. Here, we just select the appropriate profile and give it a thickness. And finally, we want to incorporate the driveways. So again, we'll select those driveways, and in this case, we'll choose a through all option and remove that. Now that we've got our property layout, we might need to use this video for presentations. Here, we can see that SOLIDWORKS allows the use of appearances. We simply drag and drop them out into the graphics area and make any minor tweaks that are necessary. We want to differentiate the property from the paved area, so we'll apply a pavement texture to the paving area as well. Now that the property's done, let's go ahead and save that file. We'll just save over our existing one, and now we'll insert that into a new assembly. An assembly is a place in SOLIDWORKS where we can combine many of our different components together. We simply choose OK, and SOLIDWORKS places the property into the assembly. We'll save this document here as well. We'll go ahead and replace our existing one. Now, we want to look at the building that's going to be in our design. Here we'll open up the existing building design. You'll notice that once I hide the walls here, we can see a very complex structural assembly. This can be done with SOLIDWORKS weldments, but SOLIDWORKS also has many solution partners which make this easy to do as well. Adding it to the assembly is as simple as drag and drop. Now we want to locate it appropriately to that 2D layout sketch. We'll simply select the appropriate origin in the layout and the origin of the building and mate those components together. We can see that the building is properly placed. There's a few other buildings we want to incorporate as well, such as the cooling tower. In this example, we can see that the cooling tower is a very lightweight part assembly. We actually aren't designing this ourselves, so we're just going to bring in some data from a supplier. Another example might be a fully self-contained process within the plant itself. In this case, our water storage site is a fully self-sufficient, self-contained system. As we insert this, we can see that it consists of a lot of different components. As we zoom in, we can see that it contains its own processes for managing the bulk water storage. So this is great. SOLIDWORKS allows us to work within subassemblies and assemblies themselves. Locating this is a little bit trickier than what we did before. We are going to still locate it to the original two-dimensional layout. We can see here that we're just going to use these center lines to locate this in place. Now the property looks a little bit goofy. We can see that the buildings don't really go through. So doing this inside of SOLIDWORKS is quite easy. We're just going to make a simple edit here. And we're going to draw a 2D layout that basically represents the outlines of these buildings. SOLIDWORKS has a lot of great tools for quickly converting geometry. In this case, we're simply going to select these faces and choose to copy the outside profiles. The water cooling tower is a little bit trickier. You'll notice here that we grab the entire boundary and a few extra edges. One of these edges is hidden. SOLIDWORKS has some great tools. Select Other is a way for us to quickly access those hidden areas of our designs. And again, we'll do Convert there. We'll simply trim these up. And we're missing an edge here, so we'll just convert one extra edge. And again, let's trim those and remove an unnecessary line. Now what you'll see here is that we can take this and remove all of that geometry from our property profile. Definitely makes it look a lot cleaner, and it'll look a lot nicer when it comes time to present this later on. We'll go ahead and save this assembly. Now that that's saved, we want to take a look at a storage tank design. We might get our storage tanks from another supplier, and in this case we need to spec that tank out. Let's give it a new name here. And how do we go about customizing this? Well, in SOLIDWORKS it's really easy. With Instant 3D technology, you can see that it's very easy for me to simply drag and adjust the parameters. However, in this case I have a very specific size in mind. 12 meters diameter by 6 meters tall. You'll notice that this part's also intelligent. It has some location sketches inside of it. These utilize a unique way that SOLIDWORKS captures intelligent information, called library features. You'll notice in this library feature it contains all of the standard ASME B16.5 flanges. We simply select some geometry and SOLIDWORKS places the appropriate feature on our tank. We can even dynamically change it to see how these changes will affect it. However, we want an 8-inch 150-pound flange on the top. We can see that it's pretty easy to rapidly apply more flanges. Here at the bottom we need to add a 4-inch flange. We'll simply select that and SOLIDWORKS will update it accordingly. We'll continue around our part and add all the appropriate flanges as necessary. We'll add a vent port to the top, and finally we're going to add a manway cover to this. We'll grab our appropriate size. Actually we want a 150-pound flange here. And again, simply select the endpoint, the line, and the surface, and SOLIDWORKS places the flange. So very rapidly, we can take some standard components inside of SOLIDWORKS, such as the tank and some smart features, and quickly build a new tank design. Now, let's incorporate this into our entire plant facility. Locating it is the same as what we've done before. We're simply going to select the origin of this point and its reference in the 2D location sketch. Now that that tank's in place, we want to look at another area of our design, incorporating some skids. We need to incorporate a pump housing into this design. In SOLIDWORKS we can quickly isolate components to get a better view of what we're looking at. Let's open this skid up. In this case, it's an entire assembly that consists of many different components. We take a look inside of it. There's a lot of components that are needed for the design, but not really necessary for the overall layout of our plant. We may want to hide some of that stuff. SOLIDWORKS makes this easy with the use of configurations. We'll create a simplified representation. Within this representation, we can suppress components, completely unloading them from memory. They're not really necessary for what we're working on, and there's no need to take a hit on performance. Let's go ahead and also configure the housing for this skid. In this case, there's a lot of extra detail that we're really not interested in the top level layout. And so here, we'll just quickly create a profile to create an envelope around this. You'll see that I'm capturing the perimeter and then the very bottom of it. We'll simply close that up. Using standard SOLIDWORKS features, we'll then just go ahead and we'll consume all of those bodies in our design here. We can see now that we have a very much more simplified representation of our water pump skid. But is all the detail lost? Absolutely not. With configurations, you can see that it's a simple toggle to switch between the fully detailed skid and the simplified skid. Let's incorporate this into our design as well. You can see with the isolated assembly, it's a lot easier to work with these components. I'm just going to drag and drop this into place, and you'll notice that SOLIDWORKS uses that to locate that part. But we might want to get a little bit more specific. Using the powerful mate command inside of SOLIDWORKS, we can locate something symmetrically. In this case, the water pump skid on its pad. The concrete pad defines the location of this, so you can see how we're just grabbing the edges in the center line of our skid, and it's located appropriately. Let's go ahead and turn the rest of the design back on and focus on another area. There is the transfer skid that went inside of this building here. Again, we'll isolate the components so we can focus on just what's necessary for this design. Now sometimes, in the case of maybe you want to do a walkthrough or a really nice presentation, you want to see all that graphical data, but you still don't want to take the overhead hit on it. Here you can see we have a lot of components in our design, and we do want to show them all. Well, SOLIDWORKS has another solution. SpeedPack, just like a configuration, allows you to simplify and reduce the amount of overhead on the system. In this case, we just select the components that we really need to reference in our top level design and hit OK. You'll notice by hovering my cursor over it, SOLIDWORKS has actually unloaded all of the other components from memory except for the flanges. This means that we get the full graphical representation of that skid without the unnecessary overhead of all those other components. We'll just locate this into place as well. You can see it's very easy for me to rotate it around and locate it just like we did before. You can see here how components are free to move and what mates are really allowing us to do, really line components up. But in this case, we can leave some flexibility in case we want to make a change later on. Now that skid's in place, what we need to do is we need to look at tying these three different systems together. Let's go ahead and isolate those as well. Creating a piping route inside of SOLIDWORKS, all we need to do is go up to the Piping tab on our Command Manager. Here we'll choose to start by drag and drop, and SOLIDWORKS will present us with our design library where we have all of our different components. Now you notice that SOLIDWORKS comes with a great deal, but we can also go to downloadable content. SOLIDWORKS supplies ASME, ANSI, ISO, and many other standards available for download. Another great place to go for content is 3D Content Central. Using supplier content, we can just go ahead and look in all categories. Here, we're going to look for motors. If we needed a motor in our design, we could simply choose it. We can see that SOLIDWORKS and 3D Content Central will supply us a list of suppliers and their components that they have in that category. If we chose electric motors, we could further dig deeper, further customizing exactly what we were after. Finally, we'd be given a choice and we'd be able to download this right into SOLIDWORKS. However, we don't need a motor in here. We're just going to use some of the routing components that are supplied with SOLIDWORKS, specifically a weld neck flange. As we drag and drop this out, all that's needed is to simply specify a size, and SOLIDWORKS routing does the rest. It understands that this is an 8-inch flange and only offers available options specific to that size. We can also use standard length tubes. All we want to do now is simply add the other flange to the other component. Zooming in, we can see again it's a simple drag and drop. As we zoom out, basically all we need to do now is connect the dots. We're going to bury this pipe underneath the ground, so we're going to go down with it first and then connect it across. We also want to make sure that these pipes are always perpendicular to each other, and you can see in SOLIDWORKS that's very easy to define. Simply dragging the sketch around, we can quickly see how our route is going to look and add very specific dimensions to it. In this case, we want to set a depth of 1 meter underneath the ground. And finally, we can even remove a pipe if we need to. We simply right mouse click and choose Remove Pipe. Once we close the sketch inside of SOLIDWORKS, SOLIDWORKS will create all the individual pipe pieces that are needed for the route. We can see them all here at 4-meter increments. Let's add one more and see if we can make this a little bit easier. In this case, we need to connect the demineralized storage tank to the pump. Again, we'll simply start with a flange and drag and drop it out onto our tank. Again, notice how it automatically snaps in place. SOLIDWORKS utilizes SmartMates to do this. In fact, if SOLIDWORKS recognizes that two components are meant to attach to each other, we don't even have to line them right up. You'll notice on the next flange, as we drag and drop, as we get near, SOLIDWORKS automatically attaches them together. Now this time, I don't want to draw all the individual route segments, so we'll use the AutoRoute capability found in SOLIDWORKS routing. You can see that SOLIDWORKS automatically connects the route together, creating all the necessary jogs in the route. Again, as we close this, we can see that SOLIDWORKS will take care of the rest for us. Let's show the rest of the components. And it's important to note, sometimes a route might need to be offset off of a feature, or in this case, the wall of the outside of our building. Notice in SOLIDWORKS, because we have the ability to create in-context relationships, it's very easy for us to specify a distance off from the outside wall of this building. Now that we're done with creating our routes, it's going to be important to create some documentation. Here, we're simply going to give this route a name. Once we've done that, we can go ahead and save it and open it up in its own window. So now we're dealing with just the individual spool that we needed to work with. We'll choose to create a pipe drawing. Simply select our sheet size in our bill of material template, and we'll go ahead and we'll let SOLIDWORKS create the drawing for us. So we hit OK. SOLIDWORKS will automatically create a bill of material and a necessary isometric view with dimensions directly on it. Very similar to an Isogen drawing, however this uses the SOLIDWORKS drawings. All we need to do is clean this up a little bit, and we have a nice drawing completed here. And as we go over and take a look at the bill of materials, we'll notice that SOLIDWORKS also automatically calculated the total quantity of all the pipes and the lengths as well. But we did mention Isogen, an industry standard. You'll notice we can export right as a PCF file for use in products like Alias, which utilize Isogen drawings. Simply hit OK, and as we go into Windows Explorer, we'll see that SOLIDWORKS has created the appropriate file. Here's our PCF file. So we've created the documentation for our pipe spool, but we also need to create overall assembly layout drawings. SOLIDWORKS makes this extremely easy as well. Again, we'll simply select a drawing and choose a D size in this case. You'll notice in SOLIDWORKS drawing creation is extremely easy. I'll place a front view and a top view. I may want to change the scale of the drawing. Again, it's very easy to create very detailed drawings inside of SOLIDWORKS that capture exactly what we're looking for. And in this case, if you need to detail the drawing, SOLIDWORKS has great tools for detailing your documentation. You'll notice here that as we're zoomed into the drawing, I don't have to worry about where the dimensions are being placed. SOLIDWORKS takes care of all the spacing and alignment issues for me. As we zoom out, we can see SOLIDWORKS has done a really nice job of this. Section views are an important part of any plant design. In SOLIDWORKS it's easy. You simply draw a line and place the view on the drawing. SOLIDWORKS automatically hatches all the individual components. We can see that we've got a pretty nice section view here. However, we're not necessarily interested in the whole depth of the assembly. We can actually set the depth inside of SOLIDWORKS. This allows us to focus on what's really important to us. Let's go ahead and take a look, and we can see that we don't see all of the components in the background. But SOLIDWORKS is really easy. You might want to put some section views on another sheet. That's extremely easy to do here as well. You just drag and drop it onto a new sheet. In this way, we can create as many section views as necessary, put them on multiple sheets, and they're all saved within one document. So documentation is extremely easy with SOLIDWORKS. We can even create things like an isometric view by simply creating a projected view. Now that we've done our documentation, there's one final part we might want to take into consideration: creating a nice presentation for our customers. A walkthrough is a great example of how to do this, and in SOLIDWORKS it's extremely easy to create a walkthrough. We'll simply define a plane that's at about eye level here. And then on this plane we'll go ahead and we'll just create a path that we're going to walk through our facility. Using the same tools we've used before, lines in this case, we'll draw out our path. If we want to make it nice and smooth, we'll create a transition using a fit spline. You can see here now we've got a nice smooth curve to walk along. Now to capture this image, we're going to have to add a camera. Imagine a worker or somebody walking through our facility actually carrying a camera, and that's actually what we're depicting here. You'll see the camera in the view on the left and what the camera sees on the right. Here we're just going to go ahead and reference that curve that we created, basically the path that we're going to walk along. We also want to make sure that the camera doesn't roll, so we'll set an option for that. And we'll define where the camera starts and stops a little bit better here. One other thing, we can change the focal length of the camera and which type of lens we're using. We'll use a standard 35mm lens here. Now that we've got the camera in place, we can go ahead at any time and reference that view. However, we want to go a little bit further, and we actually want to create an animation of this. It's extremely easy in SOLIDWORKS. We'll simply go ahead and drag our timeline out to how long we want our walkthrough to last, in this case 12 seconds, and we'll modify the properties at 12 seconds. And here we're just going to look at the end of the line as opposed to the beginning, and SOLIDWORKS automatically understands that over the course of 12 seconds it needs to follow along that path looking through the camera. It's extremely easy to create these walkthroughs, and we can see at the end we're created with a nice piece of documentation that we can share with our customers. But if we want to go a step further, we can customize it even more. We simply drag the timeline back to a point where we want to look at something specifically. We capture that timeline moment, and we're going to copy that a couple times here. And you'll see all we need to do is edit that keyframe, and in this case, instead of looking straight ahead, we're going to take a look at that demineralized storage tank that we placed on the left hand side. So here we'll just select a component in our view, and that'll change our angle that we're looking at our model. Extremely easy, right? We'll go back, we'll take a look at how this has changed our walkthrough, and again you'll see that not only is it easy, it's really easy to create really stunning and really powerful walkthrough videos here. So in this demonstration we've seen a lot of things. Let's recap. We've looked at how we can use our native DWG data or 2D data given to us by possibly a civil engineer or an architect and use that as a basis of our initial layout. We've seen that SOLIDWORKS works with solution partners to provide the ability to create structural steel frames. Again, remember SOLIDWORKS can do this itself, it's just the gold level solution partners do it quickly and easily. We've also seen how SOLIDWORKS can be used to take standard components and customize them to suit our needs. This is great when speccing out a very unique piece of equipment. We've seen how placing all these components is extremely easy, and finally how connecting them together and documenting them all can be easy as well. And finally, we've created a great piece of presentation material to share with our customers. I hope you've enjoyed this presentation.